Awesome. Well, thank you very much for attending this session, entitled WinMerge to WinOps in 365 days. Basically, it's the story of how I helped a client go from manual deployments using WinMerge to fully automated blue-green deployments inside AWS. So I'm just going to take you on a journey of the things we realized we should be doing, what we did, and then when we did them, the other challenges that we then faced. So just a little bit about Evolve Software. We're a custom software development consulting company in the UK, providing technical services to help you with the software development lifecycle. Our ultimate goal is to be able to empower you to do the things that you need to do so you can actually focus on your business and not deploying software. We look at it as though if we can do something for you and you don't rely on us, then we've done our job correctly because you are then empowered and you can continue to do what you need to do. So a bit about me. I'm actually a developer. I've been a .NET developer for 18 years. But I still do development, but I got to a point in my career where I realized that I was getting cross about my software not shipping. And I knew that there were better ways of shipping software. And it was around the time when Octopus Deploy was becoming a known tool in this area. The term DevOps hadn't been coined yet, but it was moving that way, and I could see the benefits of it. And I enjoyed doing it and being able to get my software out there. So I'm available on various different mediums. I'm reasonably active on Stack Overflow as well for TeamCity and Octopus Deploy. So a little bit about the client. The client for this case study is called Hotel Plan. They're a parent company and they own a number of specialist tour operators in the UK. And they're very diversified in skiing and walking holidays. Some of you may have booked through them, but these are some of the brands that we run and operate online. So when I first came into contact with the organisation, I did what's called a DevOps maturity model assessment. Now, the DevOps maturity model is something that was produced by ThoughtWorks, and it's really just to baseline yourself, to give yourself an understanding of, well, where are you? Where are you at? And where can you get to? And it became quite apparent as we were going through, they're doing manually building software. Pretty much everything was manual. As you can see, we're at the very bottom here. So we scored them as level -1. Pretty much their DevOps, there was nothing DevOps about it. So we identified what issues were they facing. So they had varied branching and versioning strategies. So some people would do one thing on a project one way and something totally different on another project. In terms of doing developments, they were coming from a developer's machine. So the classic, it works on my machine scenario, why doesn't it work in test or production? They had no build artifact management. So a build was just done at a particular point in time, no tagging of a release, no knowing what's going in that build. Yes, we can have a look at our Git repository and look at the history and make a gauge, no release notes, anything like that. So it was a bit of a finger in the air to say, okay, we'll do a release now. They had managed Snowflake servers. Sorry, I could just hear, I thought it was yodeling at first from next door, but it's clearly not having a good time. So they had managed Snowflake servers. So Snowflake is a term that, you need a component on the server, someone will go on and install it. Something's not working, someone will go on and tinker with it. There's also no defined standards or visibility of code quality. So they were working with external agencies on some of their projects, and effectively it was treated like a waterfall scenario, saying to the agency, here, go off and build this for me. The agency comes back, here's your code. No idea what the quality of that code was, apart from the agency saying, yes, it works and it does what it said it should. We also had many, many more issues. So it was a real spaghetti. Not just spaghetti code, infrastructure, everything was spaghetti. So the identified tools and platforms that they were running under, they had code under source control in GitHub, which is good. They're using Visual Studio 2013, SQL Server 2012, and Umbraco CMS. Are there any Umbraco certified developers in here? Awesome. Anyone else using Umbraco? Just the one? Or CMS? Cool. Okay. So we'll touch on some of the aspects that we had to solve with Umbraco. They're also using WinMerge for deployments, as I mentioned earlier. Now, I don't know about you, but if I had to do a WinMerge deployment, that would probably send me a bit crazy, just the once. And it was a high-level director who was doing these as well for a number of weeks. So we had to sort that out quite quickly. So just a brief overview, if you don't know what Umbraco is. It's an open source content management system. It's written in C#, deployed on Microsoft-based infrastructure. It's strongly supported by a very active community. And best of all, it's free. And it's pretty good at what it does. They have conventions yearly, so it's worth tipping along, and you can become a certified developer. So the current manual deployments that they were doing is that a developer would push into the Git repo, and then they would deploy from the very same machine that they did the push from. We also had other people pushing out deployments as well, and these were SQL developers. So there was no traceability of the SQL that was going on at all. No knowing what's changed on the production server. Only the SQL who deployed that change would know about it. It was up here. So what we decided was we would get some quick wins. So we would look at implementing GitFlow branching strategy. Now, if there are developers in the room, there's potentially a point of discussion on different branching strategies. What we didn't want to do was have that discussion with them, but rather suggest something and say, here's a way that will help you work. It will give you a process in order to clearly define your releases for you, and we can then build that into a pipeline. So GitFlow, allows more structured releases. There is a link on these slides which will be available, which will take you to the full definition of what GitFlow is. But it allows us to branch from the develop branch when we want to determine a feature, merge back in, and then we want to do a release, we branch out from develop, and we can test that as a beta release, and then we want to go to production, we merge it into master. And master is a true copy of what we are running in production. So I have branches for features, release, and hotfix. Releases get tagged in the repository, so it's very easy to go back to the repository and say, I want to rebuild version 1.3.1. Master branch is the true mirror of the production code, and it gives us the ability to derive semantic versioning. So semantic versioning, if you're unaware or don't use it, gives meaning to a release number. So a minor number indicates that there has been a bug fix, potentially. And each of the numbers within the semantic version tell us whether it's a new feature, potentially a bug fix, or a major release. And those things kind of indicate we should expect a breaking change on a major release. A new feature, we shouldn't expect breaking changes, but potentially, and on bug fixes, we shouldn't expect those at all. But it gave the organization consistency to understand when they were talking about a version, what it meant, how they could find it, how they could rebuild it effectively. The second quick win that we identified was we needed to get the databases under source control. So the databases were just on a server. A developer would write a script, push it against a database, write that script, push it against that database, and no tracking, no history, no change whatsoever. So we implemented SQL Source Control. So SQL Source Control is a product from Redgate. It plugs into SQL Management Studio. It gives you version control for your schemas and static data. So lookup data, for example, if you're thinking of you've got currencies and you want to add a new currency, well, you can source control that data, and when you release using SQL source control, you can ensure that that data is then in the next environment, which is probably going alongside a feature that will require that lookup data. Obviously, being under source control, it gives you the ability to see who made what changes, when, and why. And you can also lock objects when you're working on them, just to ensure that there are no clashes going on. So it's just a visual key inside of SQL source control to indicate to other developers someone is working on this table, this view, this stored procedure, so please leave it alone. It's akin to a lock on a door in a lavatory. You can still unlock it if you need to, but it's just a visual indicator that it's occupied. So SQL source control gives you a nice developer view inside SSMS. So there we can kind of see that this is a database under source control, and then these are just sort of indicating that there are changes inside the database that don't match up with what is in source control. So that would indicate that there are pending changes that need to be pushed in. So it's a great product. It's worth having a look at, playing with a trial if you've never used it before. If you're used to using RegGate tools for schema comparisons, data comparisons under the hood, that's kind of what it's using. So it should be familiar territory. So this allowed us to then change the way that SQL developers work. We've got a developer pushing into a repository. So we now have a SQL developer, a DBA, if you will, pushing into a repository as well. Generally, they were the same repository, so we considered a SQL database and the executable code to be the application as a whole, and they sat inside the same repository because generally we want to release them at the same time when changes are made. Excuse me, sorry. So another quick win that we identified was automating builds when code changes. So rather than having a developer do a build on his machine when a release needs to go out, we don't really get the feedback fast enough by doing that. What we want is, I make a change, within 5 minutes, I know if I've broken something, if my tests have run, if they've failed. I need that feedback. I need that left shift, effectively. So we identified TeamCity. Obviously, JetBrains stand is here today. I'm a great advocate of TeamCity, absolutely love it. VSTS has moved on in strides. I will give it that. But TeamCity is what we implemented. It was a nice, easy to use user interface. We're talking a year and a half ago, so they felt comfortable with it. It's a Java-based build management and continuous integration server. It supports numerous version control systems. It has a very easy to use interface for setting up build configurations. And it's got a freemium license. So you can have, I believe, up to 20 build configurations before you even need to start thinking about licenses. You can also have 3 agents, so you can build 3 configurations in parallel, again, under this freemium license. So it's got stuff going for it, and it's worth a play. So a little look at the user interface. So here we have a particular project, as you may have seen on the branding, Santa's Lapland, a very seasonal website. And this is our overview of what builds are going on. As you can see here, we're supporting many different features and branches, yet it's all building off of the same build configuration. So TeamCity, when it's connected with Git, supports branch specifications, so you can watch branches in a number of different wildcard ant-like syntax to trigger the same build, but off of different branches. And this is a little look at what our build steps were. There's a lot of stuff. If you're doing continuous integration, continuous build, you're going to be doing the same kind of things, getting your NuGet packages, building the solution, probably running your unit tests, and then pushing your artifacts off to somewhere. So this changed our continuous integration builds to now, rather than building from a developer's machine, implemented TeamCity. So implementing TeamCity was triggering a build when either a developer or a SQL developer, any of the devs, were pushing into GitHub. We would then trigger a build inside of TeamCity. So we now have continuous builds going on every time we do a check-in. If someone checks in code and it breaks, we know about it. So another quick win that we identified was single-click deployments of code, which most people strive for, most managers want, that little bit of magic. So we identified the tool as Octopus Deploy. Again, in my opinion, it is the de facto deployment tool for .NET, but not just on Windows either. It's really, really strong, especially Azure integration as well. I wouldn't choose any other tool at the moment. It is generally marketed as a release management tool for .NET. Effectively, if you can run PowerShell, Bash, C#, it's a shim for it. It's a very clever product. And a number of organizations I've been in, they've kind of written Octopus Deploy before Octopus Deploy came along. So they slightly missed the mark, unfortunately. It adds a simple UI for managing your deployment pipeline. So much like you can configure steps inside of TeamCity for building, you can do the same in Octopus Deploy for releasing. Many tasks are based on PowerShell. You can write your own custom steps in other languages that it supports. And again, it's got a freemium license. So I believe you're 20 projects inside of Octopus Deploy if you're on a free license. I've got a nodding head, so that's good. A little look at the project overview inside of Octopus Deploy. It gives us a really nice dashboard, so instantly we can see what version is in what environment and also what's ready to go. So we've got a beta version ready to go into our quality environment, obviously before we end up moving that into production. So it gives you a really nice overview on the dashboard. And again, the project configuration screens are very good, very easy to navigate around. It's quite hard to go wrong with this tool, to be honest. We've got a lot of control over running steps in different environments. I won't go too much into Octopus Deploy if you haven't used it. It's worth installing it, getting it locally and having a play about with it. It allows you to set up agents, in effect, and tag them as being on different environments. So you can then say, I want to deploy this project to test, and it will find all of the agents that are tagged as test, and it will deploy the code onto there for you. It supports Iaas natively out of the box. It supports services natively out of the box. It really is a very, very good product. So this then led us towards, brilliant, we've now achieved repeatable deployments. So no longer is the developer deploying from his machine. We are triggering a build inside TeamCity when a commit happens. We're creating a release inside of Octopus Deploy, and a release is made up of a package, and Octopus Deploy is then deploying that package out to the relevant servers. So that package could actually have SQL scripts in there as well, and it could have the application code in there as well. What we were actually doing with the applications is we did have two packages in there, and there were two steps, one to deploy the database and then one to deploy the application code. However, we had very few database changes because we were dealing with a managed system, Umbraco, and it was really only when we got the upgrades through that generally database changes would come through. Well, that was really easy. Yay, we've done some really good stuff. And to be honest, the feedback that we got was going from 0 to hero. We've given them continuous builds. They know when something breaks. We've given them single-click deployments. And actually, in their dev and test environment, they didn't even have to click anything. They just had to push their code. So we thought we were done. Well, clearly not. We then had to have a look at, well, what about your infrastructure? You know, each server has a personalized name. They're lovingly hand-raised and cared for. When they get ill, they receive treatment, and they can only be scaled up. They're basically pets. What we really wanted is for servers to have meaningless names, no identity. We wanted them to be identical to others. When they get ill, you replace them, and they could be scaled out. Effectively, we wanted cattle. So we didn't really care about the servers. They could come and go, you know, as we needed them. So we identified the tool that we were going to use. So we're on AWS as a platform. We could have used the CLI natively. We decided to use Terraform. So Terraform if you've not used it, is an infrastructure as code software. It allows you to define it in quite a high-level language, and you can actually point it at different providers. So you would be able to run this against Azure and other providers as well. And it's plain text, so you can store this inside source control. And as you're making changes to it, again, you get all the good stuff that source control gives you, which is history and why the changes and allocated against features, etc. So leveraging infrastructure as a service with Terraform. We define the infrastructure. We parameterize the scripts, if that's a word. The idea being that we could say we want a number of instances, but for different projects, we want 2 instances on this project and 1 instance on this project. So the idea was we wanted to be able to bootstrap this script. So think of it as a batch script, passing in the parameters. That was our goal. We obviously put them under source control. And at this point, we felt our servers are no longer sacred. They're just in a text file, effectively. So no more cats, which is what we were after. So we did a first iteration of our Terraform scripts. We defined an AWS launch configuration. So what this allows us to do is basically say, when you launch an instance, I want you to use this custom AMI, which is an Amazon machine image. So we tailored an image to have Iaas installed on there. We wanted file on there, NX log, and other bits of software that we wanted every instance to have. And then within our Terraform, we could parameterize that to say, you're going to use this ID. We also had parameters for the instance type. So some of our sites get a lot more traffic than others. So we just wanted them a little bit beefier. And we can also customize a startup script. So when an instance comes alive inside AWS, we want to run a bit of code for it to do something. We also defined an elastic load balancer. So this allowed us to define how to health check our instances. So when we define the balancer, we give it a URL and say, hit this URL, and you should expect a 200 response. And the load balancer inside AWS will be doing that against all of the instances, and we can say, do this every 5 minutes or do this every 2 minutes. And if you fail 5 times, then consider that instance, it needs to be terminated, it's unhealthy, and rebuild it. And we also defined autoscaling groups. So we were able to say, within this group, we want a minimum of 2 servers and maximum of 5 servers. Again, these are all parameters that we can bootstrap. So now having a Terraform repository moved us a lot more towards DevOps, because we've got dev pushing code into a repository, devs, I should say, SQL developers as well. We've now got ops pushing code into a repository as well. So dev and ops are working together. Dev can actually see what ops are specifying for the infrastructure, and they may turn around in a stand-up and say, actually, these need to be this, or we need 4 instances, as an example. We still had the same flow going on inside the build pipeline. So again, we could trigger a build, we could create a release, and the release is based on a NuGet package. However, it creates a new issue. Well, now we've got to deploy this stuff. So how do we go about that? So the new challenge is deploying the infrastructure in AWS. So we wrote a Terraform step template. As I mentioned earlier, if you're not using Octopus Deploy, you can easily write your own step templates inside there. And we define parameters for the step template. So as you can see here on what I was talking about, we can define max instances, min instances, health check URLs. So that's just going to bootstrap that Terraform script. And all that Terraform script really does is run terraform.exe, pass in the path to a script, and then pass in these parameters, which we've defined in that script. It needs a few AWS keys in order to connect to AWS, but effectively that's what it's doing, and then Terraform will go off and build that infrastructure. So we then implemented that step inside the deployment pipeline. This is a specific project, but with it being a step template, I can easily reuse it across different projects inside Octopus Deploy, so I can change the parameters for different projects. So this meant that we iterated our deployment process. We had to make a change. So we're still triggering a build when code is committed, and we are creating a release. But this time we've got a NuGet package, and we're using Terraform to execute it against AWS. And what that would do is provision of servers, depending on what parameters we've defined, which is great. So we've now got dynamic servers going on. Every time we do a build and release, we can define those, and that will happen. They will get rebuilt. But still, we had another challenge that we needed to solve. So we traditionally, in our Umbraco setup, with it being content management, we have one publishing site, which is internal, private. We don't expose the admin on public-facing sites. And we call those our read-only sites, in effect. So we had to deploy one site before we rolled it out. But it gave us the opportunity to verify that that site was good. So we wanted to deploy an admin site before rolling out our read-only instances, and so we used the manual intervention steps inside of Octopus Deploy. So we effectively halt the deployment until someone comes along and signs this off. They put their name on it. Now, that's compliance, in effect, because someone is pushing a button to say, yes, I'm doing this. They might be in a specific role that they are needed to be in order to satisfy compliance, but that satisfied our compliance. So again, we then had to iterate our deployment process one more time. So now we are deploying a site, and then we are going on to deploy to AWS through Terraform. So effectively, I didn't realize I was stood in front of it. Effectively, here, we are stopping deployment until someone comes along and says, yeah, I'm happy with that. That can now roll out into test or production. Another challenge that we faced was, how do we get an application onto instances that we don't really know about? We've just gone, create me 3 of those, please. How does Octopus Deploy know about them? So we made use of a feature called AWS User Data. It's effectively allowing you to bootstrap an instance. So an instance comes up, and one of the first things it does is it executes your script in user data. This was some custom PowerShell that we packaged in our Terraform NuGet. So we're giving all of the instructions. It executes at launch. It also has access to the metadata, custom attributes on the particular instance. So using Terraform, we're able to tag an instance. So we can say, I want you to provision me 3 instances, tag it as their environment is test, tag it as their project name is Santa's Lapland, tag it as their version is this. So the PowerShell script can actually look at those tags on the instances itself and say, oh, I'm this project, oh, I'm this environment, oh, I'm this version. So what we did was we used PowerShell script to install a tentacle. It would go off to Octopus Deploy. It would download the zip of the latest tentacle, and it would install it locally on the machine, and then effectively call home. So using octo.exe, which is a wrapper around the API, it will call home to Octopus Deploy and basically say, hi, I'm a tentacle, I'm alive. And all 3 of those instances would do that. So Octopus Deploy would know there are 3 new instances. They're dynamic. And then what it would do is it will pull the latest release version down and install it locally. So we solved the problem of getting the application deployed onto a dynamic instance that we didn't know about. So again, we had to iterate our deployment process. It was a simple enough one where the tentacle would go off and register. There will be a tentacle on each of these instances here, and it would then deploy the NuGet package. So we had one more challenge that we felt we needed to address. So Umbraco and many CMS systems generally hold a cache locally. That's what makes them good and quite efficient. So on my admin box and on my dynamic instances, they've all got a local cached copy. It's an XML file in effect. So they've taken the database, they've written it out to an XML file, so they just quickly read from that XML file when you request a page, and it's looking in that tree. Now, when our admin box is publishing content, all it's doing is updating its local cache. It's not talking to these at all. It's not notifying these. This is a new feature in 7.3, but we were dealing with pre-7.3 here. And you know, so we had to be quite inventive of that. Well, how do we tell this box that those boxes need to update their content? So we made use of published events inside Umbraco. We basically hooked into the publish event inside of Umbraco. And we said to Octopus Deploy, hey, trigger this project for us. And all the project was a simple go off and hit a particular URL on these boxes, and internally it calls a .refresh content API method, and it refreshes the content on all of the individual boxes. So we were just queuing up project deployments for something very, very simple. So Octopus Deploy would then hit these endpoints, and they would automatically refresh their content. Now, this is a problem that has been solved in 7.3 and onwards. It's got a lot smarter, but it was certainly a scenario that we had to handle. So, well, it's only 2 on Umbraco, but there is a blog article detailing exactly what was going on there. So, what have we gained from doing all of that? Well, what we've actually gained is we've got scalability here. Without really trying to achieve it, we've got scalability. We've got all of the instructions we're giving to AWS to say, when you want to spin up an instance, this is what you do. You use these parameters, you execute this code after you're done, and you go off and register and you pull the latest application. Great. So if I say I want 10 of them, it does exactly the same thing. So we've given AWS all the instructions for a new instance. Unhealthy instances just get terminated. With our load balancer, it is constantly checking, I say constantly, however we say every 2 minutes, every 5 minutes, whatever we want, just check those instances. Are they giving me a 200 response back? If they're not, terminate them and rerun that whole bit again, and we'll have another instance come up in its place. So they get terminated and they're rebuilt using the blueprint that we've already provided. We can fine-tune thresholds for scaling out and in. So within our Terraform, there's a whole lot more that we can do. So we can kind of say, well, here's your scaling point. If your CPU is above 50%, scale out for me. If it falls below 50%, scale in. So effectively terminate or give me a new instance using that blueprint. And we can refresh our cache on multiple instances, as highlighted a pre-7.3 issue. So what about downtime? Because the kind of applications that we're running is we're taking bookings. We don't want people to be going through a booking journey and suddenly about to click pay and the site disappears. So what we get inside of AWS is the user is hitting the load balancer inside of AWS, and that's hitting currently version 1. So when we decide, okay, we're pushing the next release, Octopus Deploy provisions version 1.2 using all of the tools that we've identified. What we're actually waiting for is for these to all go healthy. So the load balancer is also checking these instances to say, are you healthy? By hitting that same endpoint that we've configured inside of Octopus Deploy. Now, once they are all healthy and they all come back and they say, yep, we are, whatever guidelines we've given it to say they are healthy, what AWS will do for us is it will slowly drain the connections going from here to here. So we gradually migrate all of the sessions over. It won't kill a session until it knows a session is gracefully ended. But all new sessions will end up going on to the new version. And at that point, that becomes obsolete, and we can terminate them, not slaughter them. Mission accomplished. Come on, he had to be in there, surely. But there are obviously other issues that we can deal with. So quality breeds quality. And we realize that that's great. That frees us up to make things a lot better. We realize how good we are now. We can get better and better. And people started identifying areas where we could make improvements, which helps us in delivering software at the end of the day. So we realized that using TeamCity, we can start to build out pull requests. And we can validate they merge. So not sure if you're aware, there's probably some Git aficionados in here, but you get a separate branch when you create a pull request, which is your merge branch. And effectively, that is a branch of the pull request merged with wherever you're going to merge to. And you can build that so you can work out, I've done a pull request, will it actually merge at the point of doing a build? Or doing the merge, I should say. So we can identify that before we do the merge, and we can report back on it. We also wanted to do code analysis, so we had no visibility of what our code was looking like. So we wanted a baseline, something in the sand to at least say, okay, we're this bad, but going forwards, we don't want to get any worse. So we used SonarQube. Has anyone used SonarQube at all? Do you like it? It's a good tool. It's a good tool. So it allows you to do code analysis kind of out of the box, away from your actual project. Unless you're on, unless you're using the new analyzers now, you can pull those in. So it allows you to do source code analysis during a build. So you can track your quality and bugs and vulnerabilities over time. It supports numerous programming languages and allows you to create custom rule sets and quality gates. So if you've used code analysis inside Visual Studio, or if you've used FXCop or StyleCop, it's all of those and more. So you can also integrate this with pull requests. So we integrated it as part of an automated code review. So when someone creates a pull request, one of the first things we do is we analyze the code against our quality gates, and we write on the pull request inside GitHub any issues that it finds. Quick view of what it looks like. So it integrates nicely inside of TeamCity. There's a plugin for it here. And this is the actual dashboard if you kind of want to go and look at it. And it gives you things like code smells and technical debt and bugs and vulnerabilities and things like you've got commented out code, you've got unreferenced variables. You're not using iDisposable correctly. So it picks out a lot of the stuff that we generally miss. As mentioned before, you can also highlight these issues inside of pull requests. So what we're actually doing here is a pull request is submitted. TeamCity is doing a build, chucking it over to SonarQube. SonarQube is hooking back to GitHub and basically saying, well, no, all of these issues kind of need to be fixed. And so we actually fail the build based on code quality rules. You can do this with FXCop if you wanted to. You can do custom rule sets. It's the same kind of thing. This just gives you an out-of-band experience so you can manage it separately to anything else. So this is great having all these notifications, but it's no good unless issues are addressed. If I receive an email, how many of us have got open pending emails in our inbox that we're just never going to get? Okay, I've got thousands. So I'm a great advocate of tools that are good and unified and we can collaborate on. But it's no good unless issues are addressed. We want something centralized, really not email. People do ignore email. It's unfortunate. It's easy to integrate with additional tooling. Freemium is always a bonus as far as I'm concerned. So I would imagine most of the room are probably using this tool, Slack. Slack simplifies communication. It integrates with nearly every productivity tool available. At a simplest level, webhooks, that's all you need just to post data to its endpoint. It's got a client for desktop and mobile platforms. Hey, it's got a freemium license. So we then started to utilize that. So the team are all on Slack, and we can configure build notifications. Again, there is a plugin for TeamCity. And we start to get build notifications coming into our Slack channels. Deployment notifications. So we write a custom step in order to do that inside Octopus Deploy, and we get deployment. So these are notifications that someone needs to do a manual intervention. This deployment is going no further. And these are actual deployments going out to specific environments. We can also get infrastructure notifications. So here we have a SQL disk space issue. It's getting low. Here's a back-end connection errors. So that kind of means that that's sort of saying, I'm nearly ready to scale, perhaps I should. So we can actually react to that. So we can interrogate logs to work out, is something going on here? You know, are we being trawled? Or is this just genuinely high traffic? Normally it's seasonal stuff, and we do get spikes in our traffic. And other various notifications that we can put through to the channels. So there's one final piece that we also wanted, which was log shipping. So one of the problems that we initially had was all of our logs were on these servers. Compounds the issue when we've got dynamic instances, and so I constantly have to go into AWS console, find out how to log onto the machine and get the log out. No, it doesn't work. So log shipping. So we install on our custom AMI that is every instance is built from. We've already pre-installed these tools to ship out the logs for us, and then we can view them in Kibana and interrogate them, and then we started building custom dashboards. If we were in Azure, we would probably be moving to OMS, which is effectively the Elk stack, and Microsoft have just rebuilt it. But there are other tools available. New Relic are obviously here, and they can provide similar kinds of metrics that you're after. So where does that leave us now? So we had a look at a maturity assessment after doing all of that work, and we were happy to report that actually we'd improved in a number of areas. So we do regularly meet, we have stand-up, and we can talk about problems and instantly resolve them. Our environments are managed effectively. Provisioning is fully automated, which is an awesome win. We've got a little, we're not quite at the top, level 3 for our release management and compliance, but we monitor our environments. You can see the notifications that we're getting in Slack, so we know what is going on, and our cycle time is monitored. The place that we do fall down currently is our testing. So we've got manual testing, so catching regressions is quite hard. So a lot of this automation has been capturing it early, but sometimes we can miss stuff. So this is our main thrust at the moment, is to get our testing up levels. So we have spec flow. We write our requirements. Yeah, as a user, I want this so that I can justify what I want. And we can specify our scenarios given when thens, and then we write spec flow tests to support those. And we're happy our database changes are performed automatically. We don't have automatic rollback yet. I'm pretty sure that's one of the next steps that we will make. So we position ourselves here. So within a year, we've managed to go from -1, where we're quite regressive, to looking quite promising to being a level 2. And there's only one way that we want to go, and that's obviously up to level 3. So the overall benefits that we've got the ability to ship code, quality code more effectively. We've got self-healing test and production environments, which is brilliant. We've got 0 downtime using test and production deployments. We've got the ability to scale out or in, so we can handle spikes in traffic, which is what we get. If we do an advertising campaign, we're going to get the spikes in traffic. If I knock £400 off a villa in Italy, we're going to get the traffic. We've got centralized notifications from all of the systems involved in the software development lifecycle. And we also have the additional ability to interrogate logs for a deeper understanding if we need to. And that concludes my presentation. Do we have any questions at all?
Why the focus was very less on quality?
In terms of the testing?
Yeah.
It's one of the last pieces that we've got to. It's just unfortunately inherent in the way that we knew the code and the performance had to be good in order to really not lose the drop-off of purchases as they're going through the process. So there's quite a linear pattern in that as the performance decreases through a purchasing process, we're more likely to lose our customers. So getting performance and quality code was paramount, and regression testing is unfortunately subsequent.
How did you go about deregistering EC2s from Octopus?
Octopus, the new version supports it automatically. It's got the functionality for just getting rid of instances that are unhealthy or they don't show. Yeah. No, that was an initial challenge. We had a little batch script to do that, but they introduced that feature.
Sorry, I'm afraid we are out of time. Hang around afterwards.
Yeah.
So Matt, we get to
Yeah. Do come and find me if you want to chat.